Hello everyone, my name's Paul Maruff. I'm Chief Innovation Officer at Cogstate. As you know, in industry now, we're very interested on how we can use remote assessment, unsupervised or supervised remote assessment in our clinical trials. So in clinical trials of Alzheimer's disease with advanced severity, so that is in people with dementia, the majority of the assessments that are conducted in those contexts actually rely on discussions between supervisors or raters or doctors and the patient. But as you move earlier in the disease into the preclinical or early MCI stages, prodromal and preclinical Alzheimer's disease, the assessments that we use or start to include are measures that are much more interactive. And by interactive, I mean that they require us to present information visually for limited periods of time or collect manual responses made by individuals. We need to have individuals not seeing what questions we're going to ask them until we ask them because we don't want them rehearsed. So what the presentation we made at the CTAD meeting was considering how we have modified our Cogstate computerized instruments so that they're optimized for that interactive aspects of engagement in remote clinical trials. We're at some advantage, of course, because in developing cognitive assessments based around computers, many of the issues around technological seating of tests, of presenting information, are largely done. But what we can do now is ask, how do we then have a circumstance where the individual who's controlling the computer is in a different location to the individual who's actually taking the test, seeing the information and making the responses? And what I talked about at the CTAD meeting was how we had modified our tests to do that. In particular, the 3 computerized tests that we use in what we call a computerized PACC score, which are 2 tests of memory and 1 test of complex attention, the digit symbol substitution test. And what we could do is evaluate, or what we did rather, is we evaluated those given remotely and in person. So if you look at the data from this presentation, the 2 main aspects of validity we show are, first of all, that performance in these different contexts on these same tests is pretty much the same. You can see that average numbers of errors are the same on the memory test, the speed or the number complete are the same on the digit symbol substitution test. So in remote or in in-person assessments, performance is the same. The second important part of it is that we assessed individuals who had pre-classified, who had already been classified as having some cognitive impairment. In our study, that was that they met a CDR classification of 0.5. And we compared performance between folks who were healthy or cognitively unimpaired to those 0.5. So the second validity that we show is that the magnitude of impairment associated with a classification of early Alzheimer's disease, prodromal Alzheimer's disease, or CDR-0.5, is the same. The magnitude of the difference between healthy adults and adults with cognitive impairment was equivalent whether that information was collected in person or remotely. As we continue this work and continue to refine and optimize our tests, there's the potential that we change the design of experiments a little so that we don't design them as people are coming in, or maybe the schedule of assessments themselves. All of these things are going to have to be adjusted and iterated to get them to be optimal. But I think for the industry, it means that we're well on the way. We're really prepared to listen and understand how or what questions you're seeking to address through the application of remote tests, and then how our technology and how our expertise might fit into that so that you can answer that question optimally, or alternatively so that you can alter your design slightly so that the questions are addressed. So thanks for watching.